guys, before actually starting to solve or evaluate any derivatives of the trig functions, guys, what I realized was that I want to clarify some misconceptions that I have seen many times students find while dealing with the trig functions. So guys, there's three types of trig functions that I want to talk about, and I want to show you like the derivative for these three. First of all, there are three different ones, and one has to use different way of actually writing the derivative of these functions. So guys, I want to make sure that people who are watching these videos and people who are taking calculus, students who are taking the calculus class, do not make those mistakes, because they are like, it's very easy to kind of realize the difference, but sometimes people get confused because if they are looking at this for the first time. Okay, so guys, there's three things I want to talk about. One is if I have a function of the form sine square x. So this is one way of expressing this. The other way, guys, is sine x raised to the power 2. So whether you write it like this or you write it like this, they are basically the same quantities. Okay, so that is one of the terms I wanted to talk about, guys. The other one is if I have sine of 2x, and now here you can already see the difference. This is that if you I'm sure you guys have already taken the trig class, so this is more like sine of a double angle 2x, right? But keep in mind that the sine is not raised to the any non-linear power. It is raised to only one power here. Guys, the third one is if we have something like this, sine of x square. Okay, so these are three different trig functions. Guys, this is sine squared. Okay, if I take a particular value for x and I substitute that value for in each of these, I'm going to get a different output, again depending on what I choose for x. Okay, so guys, here's the sine function is squared. The whole sine function is squared, and I like this way more than this, but most of the times in the textbooks and everywhere you would see this form. So whenever you see this form, it is basically the whole sine function squared. So if the value for my sine function is, let's say, 1/2, then sine square x would be just squaring that 1/2, which will become 1/4, right? Guys, then sine of 2x. Now it is not squaring, it is just sine of the double angle. Whatever the value for x is, we got to multiply that by 2, double the value for x, and then apply the sine. Okay, then take the sine of that value. And then guys, the third one is again different than the previous two. In this case, first we have to square whatever the value for x is. So for example, again, if I choose x to be, let us say, 30 degrees or pi over 6 radians, then first I have to square that. So I have to square 30, and then I have to take the sine. So guys, keep in mind these are three different quantities, okay? And you are going to get three different outputs if you substitute a particular value for x. Now that being like said and understood, guys, now let us also talk about how do you write the derivative of this function, because in this case we're interested in finding the derivative or writing the derivative of trig functions. So guys, let us start with this one. So first of all, guys, please note here the power of sine is 1. There's a 1 here as well. We don't have to write it. It's an invisible 1, right? We don't write it. But here the power is different than 1. So here it is 2, but it could be 3, 4, or anything greater than 1. Now if I have something like this and I have to find the derivative of this function, so guys, the derivative d over dx of this function sine of x square. So all I have to do is, I have to treat it like a sine of an x function. So what is the derivative of a sine function? The derivative of a sine function is just simply the cosine function, but it is not just x, it is a cosine x square. Guys, here we are bringing in the chain rule again. Chain rule is the most important and most critical rule for finding the derivative, so it will just keep on coming all the time. So derivative of this whole thing is the cosine x square, because derivative of sine is cosine, and the power of sine is just 1, so we can just directly use the general formula for the derivative of the sine function. But keep in mind there is an x square, so that's why I got to put that x square. Guys, we cannot just stop right here. We know using the chain rule we have to multiply this guy by the derivative of the inner, and in this case the inner is the x square function. So what is the derivative of x square? You can use the power rule on that. It's just simply 2x. So you can rewrite this as 2x times cosine x square. That would be the derivative of this particular function, this number 3. Now guys, let us look at this function here. Again, the power of sine is only 1. There's an invisible 1 here. What is the derivative of sine? Guys, we can still simply use the idea that the derivative of the sine is just the cosine. So derivative of this function would be cosine. but not just x. There's a 2x, like a double angle, so I got to have a double angle here. But I cannot stop right here. I still have to multiply by the derivative of the inner. And the inner function here is this 2x function. What is the derivative of 2x? It's just simply 2, right? So times 2. And we can rewrite this as 2 times cosine of 2x. So you can already see the difference. There's a difference in this function between this, and obviously there's difference in the when we calculate the derivative of these functions, right? You can already see that, guys. There's an x squared here, there's a 2x here, and this is multiplied by 2x. This is only multiplied by 2. Now comes the trickiest one, guys. This one, the power is not 1 anymore. A power is different than 1. So every time you have a power different than 1, when you are dealing with the trig functions, and guys, it also works with when we are working with polynomial functions as well. Think about, so here let me first show you an example because we have already covered, and I'm expecting that you already have seen the chain rule. So guys, let us say we have a function which looks like this, like an algebraic function. Let's say I have x squared plus 2x raised to the power 2. And I have to find the derivative of this. Guys, to find the derivative of this, one has to use the power rule, and you can also think of that as using the chain rule, right? So how do we find the derivative of this? Guys, if you remember my technique of doing it, I treat this whole thing as a big X, and so it's x to the power n. So first I use the power rule on it, and then I multiply by the derivative of the inner, which is basically using the chain rule, right? Guys, we are going to do the exact same thing with this guy as well. So the first step is going to be, we got to treat it, this whole thing. Guys, I'm going to treat this whole thing, whether it's sine x or it's more than sine x or anything different than sine x. I'm going to treat it like a big X to the power 2 or x to the power n. In this case, n is 2. Guys, n can be anything greater than 2, right? So using the power rule, this is going to be 2 times sine of x raised to the power 2 minus 1, which is just 1, so I don't have to really write it. It is understood that it is raised to the power 1, but then we cannot stop right there. We have to use the chain rule, and chain rule says you got to multiply by the derivative of the inner. In this case, whatever is inside the parentheses. In this case, the piece inside the parentheses is sine x, so you have to multiply by the d over dx of the inner. In this case, guys, again, it's as simple as sine, so I'm just going to write sine x. Now, moving on to the next step, what is this going to be equal to? It's 2 sine x, and derivative of sine x is cosine x, so that is it. Guys, if you have a trig formula sheet in front of you, there's a sine double angle identity which says that 2 sine x cosine x is just sine 2x, but it's not a big deal. If you leave it like this, that is totally fine. But if you remember, or you have a trig formula sheet in front of you, then you may want to write it as sine 2x. But in any case, guys, please look at these functions on the left hand side. Obviously, we can see that they are different functions from the left hand side as well. And when we take the derivative, and we have to treat them differently based on what the function is. Guys, when the powers of sine are 1, or for that matter for any trig function are 1, then you start with the basic rule and then multiply by the derivative of the inner. Guys, but when it's squared or raised to the power something more than 1, then one has to first kind of use the power rule, like treat this whole thing as x to the power n, and then multiply by the derivative of the inner. In this case, inner was as simple as sine x, and we know the derivative of sine is just cosine. That's how we got this. So the left hand sides are different in their own way, and the derivatives of each of these functions are obviously also going to be different. So guys, please make a note of this carefully, and then I will see you in the next video with examples, and we'll try to evaluate the derivative of different trig functions. Okay, till then, take care. I will